Hello everyone. Hello everyone and a warm welcome to you to attend this webinar. Before we move to the topic, it is very important to clearly understand what. Hi everyone. Uh, before we move to this topic, modern trends, it is very important to clear understand what civil engineering actually is and why it is so important to the subject of proficiency. Civil engineering is one of the oldest engineering fields in world. In fact, civil engineering started when human beings first being to live in communities and needed shelters, roads, and waters. Ancient civilization like Egypt, Roman, and Indus Villa and perfect examples of early civil engineering structures like the pyramids and ancient roads are still standing toward, which shows strength and importance of civil engineering. Let me explain step by step the design. Design means planning and preparing drawings and calculations before any construction starts. A civil engineer designs structures to make sure that safe, strong, and economical and comfortable to use. Design includes size of building, types of material, load carrying capacity, safety against wind load, earthquake, and other forces. Today, design is done using modern software like AutoCAD, ETABS, StatPro, and Revit, but the basic engineering principles remains the same. Then, construction. Construction is the very Construction is the stage of where design and converted into real structure. Civil engineering manage site work, labor, material, equipment, salary of site, safety of site. They make sure construction is done according to drawing specification and quality standards. A small mistake on site can lead serious problems later. So a civil engineer play a very responsible role during construction. Maintenance. Maintenance. Civil engineer not not end after construction. Maintenance is equally important. Roads, bridge, and buildings and dams need regularly inspection, repair, and strengthening to ensure long service life and public safety. For example, repairing cracks and buildings, you know, strengthening old bridges, maintaining highways and drainage system. Now let's talk about civil engineering. Includes civil engineering covers a wide range of infrastructure such as buildings, uh, buildings, residential, commercial, industrial, roadways and highways, connecting cities and village, bridge and flyovers for smooth transportation, dams and canals for water storage and irrigation, airport and railways and metro. metro system, water supply and sewage system. Basically, every physical structure around us is a result of civil engineering. That is why civil engineers are often called it national buildings. Without civil engineer, there would be wouldn't be no development and no transportation and no modern cities. In today's world, civil engineer is not longer limited to manual work and traditional methods. It has evolved with new construction technologies, advanced materials, digital tools, sustainable parts. That is that is why understanding both traditional fundamentals and modern trends is extremely important to today's civil engineers. Civil engineers is a core of evergreen fields, but success depends on continuous learning and skills upgradation. With this understanding, us let us now move to next topic. Why modern trends are important. Increased population and urbanization. First reason of increased population and urbanization and rapid urbanization. Every year the population is growing and more popular moving from village to cities in search of jobs, education and better living standards. Because of this, cities are become overcrowded, depend for house is increasing, more roads, flyovers, metros and public buildings are required. Traditional conduct, Traditional construction methods are slow, labor dependent, less efficient for to building more infrastructure in less time. We need advanced planning, modern construction techniques, and digital tools. Without modern trends, is impossible to meet the infrastructure needs of a growing population. Next point is need for sustainable infrastructure. The second very important reason is the need of sustainable infrastructure. Early constructions mainly focused on strength and cost, but today we must also think about environmental protection and energy saving, water conservation, reduce population, and traditional construction. And then traditional construction causes higher carbon emissions, excessive use of natural resources, large amount of waste. Modern then Modern trends promote green buildings, eco-friendly materials, energy efficient designs, uh, rainwater harvesting, and solar energy. Then next point is sustainable infrastructure in ensuring that present needs are met, future future generations are not affected. Then next point is technology technology advancement. Today, technology advancement is changing very industry, and civil engineering is no exception. Early drawing were made manually, collection calculation were time consuming, errors were found only after construction. Today we have software like AutoCAD, ETABS, and STAD and Revit, BIM for 3D modeling and coordination, drones of site inspections. AI is analyzing decision making. Technology helps better access accuracy, reducing errors, improve collaboration, better planning and monitoring. Companies know expect civil engineering to technical skill, not only side basis. The last point is faster and safer construction methods. The fourth reason in the faster and safer construction in in modern projects. Time is more money. Daily causes huge losses. Safety is a top priority. Then traditional construction methods often involve high manual labor, high risk of accident, slow execution. Modern methods such as mod- modular constructions, advanced machinery, autonomous automation help in faster project completion, better qualification, reduce on-site accidents. Then next point is smart city concept. In smart city concept, we see about the integration of technology in infrastructure. In traditional cities, infrastructure like roads, water supply, electricity, and drainage work independent. In smart cities, technologies and ingredients directly into infrastructure. This means scenario of scenario are installed in roads, buildings, pipeline, and bridges, and data is collected continuously. Then systems are monitored and collected, controlled digitally. For example, scenarios in building bridges detect cracks or vibrations. Smart streets, lights turn into the off automation autonomical. Buildings are monitored for energy uses. The integration helps authorize, authorities detect problems early, reduce maintenance cost, improve safety and efficiency. The next point is efficiency efficiency of transport and system. One of the biggest problem in cities is traffic congestion. Smart cities focus on efficiency transport system. This includes smart traffic signals, change based on traffic flow, GPS based public public transport tracking, smart parking system that guide drives to available parking. In some cities, traffic signals reduce waiting waiting time. Metro and bus routines optimization data. Accident prone areas are identify the identify improve. This result is reduced traffic jams, less fuel consumption, low population, time time saving citizens. Then next point is smart water and energy management. Water and energy is very important resource, and their wastage is major issue in traditional cities. Smart cities use technology to manage water and energy efficiency. Smart water management sensors detect water leakage in pipelines. Uh, digital meters measure water uses. Rainwater harvesting systems are monitored. This is help reducing water loss, ensure quick water distribution, planning future water needs. Smart energy management. Smart meters track electricity uses. Solar energy is integrated into building. Energy efficiency lighting system are used. As a result, electricity bills and are reduced. Power wastage is minimum. Cities become more sustainable. The next point is improved quality of life. The final of the important goal is smart cities improve quality of life. Smart city developed leads to better roads and transports, reliability, water and electricity supply, cleaner and environmental, improved safety and security. Other benefits includes better waste management, faster emergency response, digital surveys for citizens. People spend less time stuck in traffic, face fewer self interruption, and enjoy a healthier living environment. For a civil engineer point of view, this means design citizens that are people friendly, eco friendly, and future friendly. Then the next slide is about green building technology. Green building technology focus on construction buildings in a way that is environmental friendly, energy efficient, and sustainable. The aim is not only to build strong structure but also to reduce harm to the environment and create healthier living space for people. Let us understand concept of Green building technology. Environmental friendly. Environment friendly construction. Friendly construction means building in a way that causes minimum damage and natures. In traditional construction, large amounts of nature resources are used. Construction waste is high. Population level is increased. Green building construction focus on using eco-friendly material, reducing construction waste, protect natural surroundings. Example includes using fly ash bricks instead of clay bricks, using construction waste, proper proper site planning to protect trees and soil. The approach of ensure that development happens without destroy the environment. Next point is energy efficient material. One of the main goals of green buildings in energy consumption. Energy efficient material helps reduce the use of electricity for lighting, heating, and cooling. Examples for energy efficient materials and techniques: high performance glasses that reduce heat transfer, thermal isolation walls, roofs, energy efficient doors and windows, reflective roofing materials. Green buildings are also designed to use maximum natural daylight, improve natural ventilations. This results in low, low electricity bills, reduced dependency and artificial lighting and air conditioner. Comfortable indoor environment. Civil engineer must understand material selection in building orientation for energy efficiency. Next point is reduce carbon footprints. Carbon footprints means the total amount of carbon or carbon dioxide released due to construction and building operations. Traditional buildings contribute heavily to car- carbon emission, global warming. Green building technologies helps reduce carbon footprint by using renewable energy source like solar power, using local available material, reducing energy consumption, improving building life cycle performance. For example, solar panels reduce dependency on fossil fuels. Rainwater harvesting use reduce energy use for water pumping. By reducing carbon footprints, green buildings support sustainable development and environmental protection. Next point is LED, lead and griha creation, greification. To ensure the to ensure that buildings truly follow green buildings principles. Certification systems are used. L leads means leadership in energy and environmental design. It includes international green building certification, focus on energy efficient water conservation materials and indoor area qualities, widely used in commercial and large infrastructure projects. GRIHA means green rating for integrated habitat assess, assignments. India's in, India's national green building rating system developed for Indian climate and conditions, used in government and private projects. These certifications starts standing standards for green constructions, improve building value and reputation, reduce operation cost over time. Next is building information and modeling BIM. BIM is, are separate change changes in one drawing may not reflect tabs, walls, doors, windows, and surveys is modeling digitally. Each element content information such as size, material qualities, and cost. This means VIM is not doing it, it is building virtual before construction physically. This helps engineers introducing the project clearly even before construction starts. Next is improves collaboration. One of the biggest advantage of BIM is better collaboration. In real project many teams works together. Architecture, structural engineers, MEP engineers, contractors, project managers. In traditional system, each team works separately. Coordination issue are common. With BIM, all teams work on a single shared model. Change made by one team are visible. This improves communication, coordination, and efficiency. As a result, project excavation becomes smoother, reduce errors and costs. Errors in construction can be very expensive. In traditional methods, errors are often discovered on site. Rework causes delay and cost increase. BIM helps reduce errors by identifying design issues earlier, detecting clashes before construction, improving accuracy in quality estimations. Because of these materials, wastage is reduced, rework is minimized, project cost is controlled. Companies prefer BIM because it saves money and time while improving quality. Next is widely used in modern projects. Uh, Today, BIM is widely used in modern construction projects such as high-rise buildings, IT parks, and commercial compliance, airports, and metros, metro projects, hospitals, and smart city projects. Many government and private organizations have made BIM mandatory for large projects. Rules like BIM engineer, BIM modeler, BIM conductor are in high demand. For civil engineer students and professional learning, BIM opens door to better jobs opportunities, higher salary packages, internal project. Next is use of artificial intelligence in civil engineering. Many students worry about AI will replace engineers, but the truth is AI helps civil engineer work smarter and faster and safer. AI supports decision making and analyzing large amounts of data that human cannot process easily. Let us understand how AI is used in civil engineering in details. Predictive maintenance of structure. One of the most important use of AI in civil engineering is predictive maintenance. In traditional maintenance, problems are detected on after damage occurs. Repairs are costly and sometimes dangerous. With AI, sensors are installed in buildings, bridges, and roads. Data such as vibration, stress, cracks, and temperature is collected. AI analyze that data and predict further problems. For example, AI can predict when a bridges may develop cracks. It can identify weak structural elements. Maintenance can be done before failure happens. This improves safety, structural life, maintenance planning, cost efficiency. Predictive maintenance is widely used in bridges, tunnels, and high-rise buildings and dams. Next point is automation in civil engineering. Another major application of AI is automation in construction. Traditional construction release heavily or manual labor, which can be slow, risk in construction, in quality. AI help automate many construction activities such as automated equipment and machinery, robotic bricklaying, and concrete pouring, automated material handling. AI-based system can monitor construction before comparing actual work with panel with plan issues, detect delays early. Automation results in faster project completion, better quality control, reduce dependency on material labor, improve work safety. Large construction companies are already invest high, heavily in automation. Next point is risk analysis and safety monitoring. Construction sites are highly high risk environments. AI plays a major role in risk analysis and safety monitoring. Using AI cameras and sensors, monitoring the site continuously, unsafe unsafe uh, activities and det- detected in real time. Workers not wearing safety equipment are identified. AI can predict accident pro- prone zone on sites, analyze weather condition and site risk, alert management before dangerous situation occurs. Benefit includes red- reduction in accidents, improved worker safety, better compliance with safety standards. In further, AI-based safety system will become mandatory in mm, major projects. Role of civil engineers in AI era. It is important understanding that AI doesn't replace civil engineers. AI supports civil engineers in making better decision making. Civil engineers still needs tech, technical knowledge, engineering judgment, sites expensive experience. AI simply provides data, divine insight that helps engineer performs better. Next is prefabrication and modular construction. Faster construction projects. One of the biggest advantage of prefabrication is speed. In traditional constructions, ac- activities happens on after another, one after another. Weather condition can causes delays. In prefabrication, manufacturing and site precipitation happen at the same times. Factory work is not affected by rain or stream weather. For example, while foundation are being prepared on site, structural elements are manufactured in the factory. This parallel process reduces total project time significantly. That is why prefabrication is widely used in housing projects, hospitals, schools, metro and infrastructure projects. Next is reducing materials wastage. Material wastage is a major problem in traditional constructions. At site, excess concrete is wasted. Material is damaged due to poor storage errors, causes rework. In prefabrication, material are measured accurately. Production is controlled and planning. Waste is minimized. This results in less work wastage, cleaner construction sites, lower environmental impacts, reduce wastage also support sustainable construction practices. Better control. Quality control is much easier in prefabrication. In factory condition, work is done using machinery and problems. Skilled laborers follow standard procedure. Quality checks are performed at every stages. As a result, uniform quality is maintained, structure strength is improved, few fewer defects occurred. In traditional site construction often faces variation of workmanship, quality issues due to weather or labor skills. That is why prefabrication components are often more reliability and durability. Next is effective methods. The initial setup cost of prefabrication may seem high. It is effective in the long run. Cost saving company from reducing construction time, lower labor cost, less material wastage, reduce rework. Faster company also means earlier project delivery, faster return on investment. For large scale project, prefabrication significantly reduce overall project cost. Where is prefabrication commonly used? Prefabrication is modular construction are widely used in mass housing projects, hotels and hostels, hospitals, including buildings, infrastructure projects. Many countries and modern country constructions companies prefer these methods for speed and efficiency. Next is 3D printing in constructions. What is 3D printing in construction? 3D printing is 3D printing in construction is a process where building components are created layer by layer using special construction printers. Instead of brick and manual labor, a printer deposits con- concrete or other materials. The structure is built based on the digital design. This process is automated and controlled by computer software. First point is rapid construction technology. One of the biggest advantage of 3D printing is speed in traditional construction. project takes months of years. Many manual steps are involved. With 3D printing, small houses can be printed in a few days or even hours. Continuously, continuous printing speeds up constructions. For examples, emergency shelters, affordable housing projects. This makes 3D printing very useful in affected areas, mass housing requirement, remote location. Rapid construction helps meet urgent infrastructure needs, reduce labor requirement. Construction industry heavily depends on manual labors. How today skilled labors are expensive and storage are commonly. 3D printing reduce labor requirement because machines perform most of the work. The next point is innovative architecture possibilities. One of the most exi- existing advantage of 3D printing is design freedom. In traditional construction, commonly complex shapes are difficult and costly. Curved structure requires special formwork. With 3D printing, complex and curved design are easily create customized architecture from the possible. The next is advantages advanced construction method materials. Self-healing concrete. Self-healing concrete is special type of concrete that can repair its own cracks automatically. In normal concrete, cracks form due to shrinkage load or temperature changes. Water enters cracks and causes of corrosion. Materials become costly. In safe healing construct concrete, special material like bacteria or microbes are added. When cracks appear, these materials react to moisturizer. Cracks are sealed automatically. Next is the high preference concrete. Performance concrete is designed to provide better strength and durability compared to normal concrete. Characterization of HPC, high high compressive strength, low permeability, better resistance to chemical and weather. HPC is commonly used in high high-rise buildings, flyovers and building bridges. Heavy loads are structures. Then next is the fiber reinforced materials. Fiber reinforced materials includes fibers mixed into concrete to improve performance. Common fibers used steel fibers, glass fibers, synthetic fibers. These fibers improve tensile strength, reduce formation, increase impact resistance. Then the next point is sustainable construction. Sustainable materials focus on reducing environmental impact. Using include fly ash concrete, recycled aggregates, bamboo and eco-friendly materials. Advantage: reduce carbon footprint, construct, conser- conservation of natural resources, lower energy consumptions. Next is role of drones in civil engineering. Drones, also known as unmanned aerial vehicles (UAVs). Then site inspection and surveying. In traditional surveying and inspection, engineers had to physical to physically visit every location, surveying large or difficult areas took a lot of time. Risk was high in highly river or high-rise built areas with drones. Next is progress monitoring. Monitoring constructions progress in very important in clear progress monitoring depend on manual site visit reports and photographs. With drones, next is progress and monitoring. Next is improved safety. Construction sites are high risk areas. Drones helps improve site by safety by inspecting dangerous location without humans enter, monitoring unsafe activities on site, reducing needs for engineering to work at heights. Then next point is geographical information system (GIS) used for mapping and planning. One of the primary use of GIS is mapping and planning. In traditional planning, maps are prepared manually. Updating information was difficult. Data data from different sources was hard to combine. With GIS, digital maps are created and uploaded easily. Helps in urban developments. GIS is the major roles in urban development and city plannings. Cities are a complex system with residential areas, commercial zones, industrial zones. Then next is management application. GIS is extremely used in disaster management. Before GIS used for hazard mapping. Then next is sustainable transportation system. Metro and rapid trans, transit system. One of the most effective sustainable transportation solution is metro rail and rapido transition system. Next is electric vehicle infrastructure. Electric vehicles or EVs are an important part of sustainable transportation. Unlike petrol or diesel vehicles, EVs produce no no direct emissions They reduce and air and noise pollution. Next is smart traffic management. Smart traffic management use technology to control and optimization traffic flow. Traditional traffic signals work on fixed timings. Do not respond to real traffic condition. Smart traffic system use sensors, cameras, data analysis. Next is water resource management. Rainwater harvesting. Rainwater harvesting is one of the simplest way and most effective methods of conservation. Rainwater harvesting means collecting rainwater from rooftops, roads, and open areas, storing in it or recharging groundwater. Next is smart irrigation system. Smart irrigation system. Agriculture consumes a large portion of available water. Traditional irrigation methods use excess water, causes water wastage. Next is fluid management technologies. Fluids are fluids are one of the most common natural disasters. Traditional fluids control methods, dams, embankments. Modern fluids management technologies include fluid forecasting system, GIS-based fluid mapping. Next is earthquake resistant structure. Importance of Importance in seismic zones. Many parts of the world, include India, lie in seismic zones. Seismic zones are areas where earthquake risks in high groundwater shrinkage can be survived. Then modern design techniques. Modern earthquake resistant design used advanced techniques to absorb the resist seismic for- force. Some important designs concepts include ductile design, shear walls, based illusions. Next is safety standards and codes. To ensure safety, civil engineers must strictly follow design codes and standards in India. In important earthquake related codes include IS 1893 earthquake load calculation, IS 456 reinforced concrete design, IS 1392 ductile detail structure. Next is challenges in modern civil engineering. High initial investments. One of the biggest challenges in modern civil engineering is highly initial investment. Modern techniques such as smart cities, infrastructure, BIM, AI-based system, advanced construction materials, is skilled work. Next is skilled workforce requirement. Another major challenges is requirement for a skilled and trained workforce. Modern civil engineer is no longer limited to brick, cement, and steel. Next point is technology adaptation issues. Adaptation Adopting new technology is not always easy. Commonly, adaptation issues includes. Next point is further further scopes in civil engineering. Smart infrastructure development. Smart infrastructure development is the backbone of further cities. Smart infrastructure used sensors, Internet of Things, data analysis to monitor, manage structures in real time. Next is sustainable urban planning. Sustainable urban planning. Rapid urbanization is create pressure on land, water, and energy transportation. Sustainable urban planning focus on create cities that are environmental environment friendly. Next is automation and robotics. Automation and robotics are transferring construction practices. Automation includes robotics, construction equipment, automated surveying, and monitoring, AI-based planning and execution. Next is career opportunity in further civil engineering. The further of civil engineering offers opportunities in smart city projects, sustainable infrastructure development, BIM, GIS, and AI-based designs. Structural engineer. A structural engineer is responsible for design, structure, and design structures that are safe, strong, and durable. They work on buildings, bridges, towers, individual structures, industrial structures. BIM engineer. BIM engineer works for building information modeling technology. BIM is digital representation of architecture, structure, and MEP components. Environmental engineer. Environmental engineer and environmental focus on protecting environment and ensuring sustainability development. They work in areas such as water, wastewater treatment, solid waste management. Next is construction project manager. A construction project manager is responsibility for planning, executing, and completing project successfully. Key responsibility include project rescheduling, cost control, and budgeting, resource management. Next point is case study explain. Example of smart city or green building project. Project overview. Smart city development with green building principles. The project used designed to handle increased urban population, re- reduce environmental impact, improve quality of life. The city includes smart residential buildings, Next point is key features and benefits. Key features of the project. Smart infrastructure. The project use smart sensors monitoring systems, sustainable construction particles, environmental friendly materials are used, energy efficiency. Key, key energy efficiency features includes water management, smart transportation, and next point is benefits of projects. The project delivering multiple benefits, reduce cabin footprint, low energy and water consumptions, improve safety and comfort. Next point is last lesson learned from the case study. This project provides important lessons for civil engineers. Technology integration in essentially combining civil engineering with technologies improves project infrastructure efficiency and performance. Sustainability reduce long-term cost. Planning is the planning is the key to success. Suc- Skilled professionals are required. Then next point is conclusion. As we come to the conclusion of today's webinar, let's us reflect on what we have learned about modern trends in civil engineering. Civil engineering is not longer limited to traditional construction method. Today, it is belong completely transformed by modern technology involves evolutions and sustainability. Modern technologies and modern technologies transforming civil engineer, engineers has changed the way civil engineers plan, design, construction, and modern infrastructure. Technologies such as BIM, GIS, AI, automation, drones and smart sensors, advanced constructions, sustainable particles and essential. Sustainable is not just a trend, it is a necessary for the further due to climate condition, climate changes, rapid urbanization, resource depletion. Civil engineer must be design infrastructure that is eco-friendly, environment friendly, resource sustainability. To conclude, modern technology i- is research, civil engineering, the sustainable practice are the fundamental foundation of further development. As civil engineer, we are not just a builder of structures, we are builders of society and the further. Thank, thank you for your time and attention.